Thank you, Dr. Mittaz, for your very illuminating talk. Now, I think we can have over the next 10 minutes, we can have a few questions on all the the last 3 to 4 talks actually that were there. So if there are any questions.
Yep. Hi, Chris. I have a question about your TRISHNA talk. I'm wondering if the fifth channel that we have, basically, so we have 8.9 and 9.2 instead of the 9 micron channel that TRISHNA have. So we have one additional one. I wonder if you have any idea whether that could improve the coastal SST performance for a similar algorithm to be applied to LSTM.
Well, it certainly will do no harm if you have the right algorithm. It may help beat down the noise. Whether it will, I mean, one part I didn't mention in my talk was the issue of cloud detection, which is just as important as the SST retrieval. And in general, I haven't yet explored whether which of the additional channels help with that step. And it could be that having 3 channels disambiguates cloud from the surface as well. So that's an important thing that is yet to be looked at. But in general, having an extra channel, if it's no more noisy, will beat down the noise overall if you use all the channels within the retrieval. And it possibly can disambiguate some of the water vapor correction better too. So it shouldn't make it worse, so long as it's well characterized.
I have one question for Dr. Jonathan Mittaz. And you talked about that 8.7 micron spectral band. Yes. And the bandwidth or spectral width is constrained by NADT. So basically, actually, are you hinting towards the bandwidth? Actually, the minimum bandwidth that you need to have to get sufficient NADT, or there's something more to it?
Well, we're looking into the width of the 8.7 micron channel. It's going to be, I mean, as you saw with the LST plots, if you remember them, that the emissivity variations are actually quite constrained within that band. So that will put a constraint on the width. But the thing I didn't say is that with all these optimizations, not only do we have to optimize them in terms of a theoretical retrieval, but we also have to know what the NE delta T is. So you don't want to make it too narrow, because then the NE delta T will get larger, and then you will add noise to your retrieval. So it's going to be a combination of where it fits best from a retrieval point of view, but also what happens to the noise.
And one more question regarding your options of having 2 black bodies versus 1 black body and deep space actually. So the second option of 1 black body and deep space, how does it compare with having actually in terms of like pros and cons with respect to having 2 black bodies on the
in respect of what?
In terms of having the merits and demerits, I'm telling that like 1 black body and deep space, yes, that is one option. Another is that you are having 2 black bodies. Yes. Assuming that deep space is not an option, so you are having 2 black bodies versus 1 black body and deep space. So how do they compare?
Well, I mean, the uncertainties show that, I mean, the beauty of something like SLSTR from an SST perspective is you have 2 references very close to what you're trying to retrieve, and therefore calibration errors get minimum. I mean, some calibration errors like nonlinearity go to 0 where the black bodies are, and if you're interpolating between the 2, you get a much smaller error. Even if you are in error, it sort of minimizes your error and pushes them down. As soon as you start extrapolating all of the things to do with nonlinearity and spectral response function location, all that kind of stuff, you're extrapolating into things which are in error, and it just gets bigger and bigger and bigger. Now, of course, if you have 2 black bodies, this is why I said that with 1 black body in space, you effectively have to remember that space is another reference. And so as you get closer to space, again, you're beginning to reduce the error. And so it does better at the cold end than the 2 black body case. But in terms of the one black body case, the thing that we haven't looked into yet, probably we may not even look into it in great detail, is the error distribution that you get with one black body in space will be dependent on where you put the temperature of the black body. Because again, when you're near the black body, the errors are small. And that would then comes down to, well, what are you trying to retrieve optimally if you have that configuration? And so you could say, if I want SST, maybe I'd set the temperature at 280 Kelvin, because that's, or 285, because that's in the middle of the SST regime. But then the LST people would complain because you're extrapolating a long way. So the one black body case is actually not really to be considered for a number of cases, apart from if you're really thinking about cold, or if you set the black body really hot and then the land surface temperature and the fire people will be happy, but the SST people will hate you. Whereas with two black bodies, you at least have the option of setting a range where you know everything is going to work quite well. And at the moment, SLSTR is set for SST. Maybe we want to heat the second black body up a bit more to help the land surface temperature people. That's something that we will look into.
Thank you so much. Thank you. Any other question?
Thanks for such a nice presentation on LSTR. Actually, my question is related with, as you shown that there is an introduction of 8.7 micrometer channel, particularly for LST, and it shows improvement. So actually, this question has a two-part. One, why we are going for 8.7 instead of 10 micrometer if we are concentrating more on SSTs, as we have channel like 10, 11 and 12 in ABIs and Himawari. So is it constrained by like, as we are also intending to retrieve LST, or it is
Yes.
only perspective for the SST?
No, I mean, I think they are trying to move the SLSTR away from being a SST prime mission into being an SST and LST prime mission. So LST is more important than maybe it was considered back in the days of the sort of ATSR or whatever. So land is equally important to the mission, I think, as SST, although Steffen may be able to say whether or not that's ESA's point of view, but I think that's what I get. Yeah.
Okay.
Yeah, just to confirm, that's I would agree with that.
That's my understanding.
Yes.
Yeah.
So the another part, if we are introducing 8.7 and we are seeing an improvement in SST, so like why we are not trying for another band in terms of 10, because definitely it is going to improve the
What
SST.
you mean 8.7 plus?
Yes, plus 10.
I think that's a cost thing.
Okay.
I think, or it may be a design thing. I mean, at some point you have to either worry about cost or worry about how complex the design is going to be.
Resources.
Because in ABI, we do have the similar sort of channels like 8.6, 10, 11, and 12.
Yeah.
Apart from it, we also have 13.
But with a conical scanner, maybe you have space limitations because the scanning is more constrained. I mean, the fact that when we started the project, we were given a list of 4 channels, and at the beginning, Paolo said, "We hope you will only select 2." I think that was what told us that the way things were going, that if we said, "Oh, but why don't we add a 11.5 micron channel or a 13 point something micron channel or whatever," we were told to keep within the remit and reduce the number of channels. And that will either be a cost, a weight, or a design issue, I'm sure.
And my another question is related with the SRF shape, as you told. So it is just a short thing that whether the shifting of SRF is more important than the shape of SRF, which one plays a more important role? Like,
well, I mean, like I said, the whole shape thing is made complicated by the fact that not only are you trying to optimize potentially the signal that you need to add to your retrieval to help your retrieval, you also are worried about the NE delta T. And so in terms of the whole shape thing, we're still at the initial stages of trying to work out what works best, what what doesn't. So I showed for SST, we first just shifted the SST and we got those distributions. Now we're starting to say, what about full width half maximum? What about shape? And we will look at the dependence of the because it's all driven by uncertainty. So we will be able to work out, does a shift minimize the uncertainty faster than a full width half maximum, than faster than a shape? But like I say, for LST, they are actually reasonably well constrained by their requirement on their emissivity detection to a particular width, and then they've already said that they think that ideally they would make it narrower, but then they'll run into any delta T problems. So it could very well be that the 8.7 micron channel is more determined by the LST retrieval than the SST retrieval, and I think that the SST retrieval will be okay anyway, because as Chris was effectively alluding to, you add a channel, you reduce the noise. And I think that's effectively what's going on. Of course, the 8.7 also has the advantage that it's used in certain missions for dust detection, Saharan dust detection as well. But the niceties of exactly how it's shaped, it's not just an SST problem anymore, it's an LST problem, and my instinct is that the LST side of it might drive it more than the SST.
I have just one question. AOD, you have considered two bands, 0.44 and 1.24 micrometer.
Yes.
Generally, SWIR band 2.1 micrometer.
That's there already.
That is already there.
That's already there. Yeah,
but
so,
what is the reason behind considering this 1.24?
It's, as Steffen said, as far as I know from when we did the original analysis, the AOD people said, I asked them, do you need the 1.24 micron channel? And they said, well, not really. But the AOLCI people need something there, and they can't put it into AOLCI, is my understanding. So the idea is that it goes on to ASLSTR to support AOLCI. So it's not really part of our retrieval AOD question, it's actually supporting AOLCI. The AOD people said, we like the 0.44. That's what they said.
Just to comment on that, it was basically a strong request from the Ocean Color community to have additional SWIR channels on the AOLCI instrument, and that would have been exploding the instrument design to quite a large extent. And so basically, it was a compromise to provide that channel via the SLSTR instrument by including the 1.24 one. It's the main application area for atmospheric correction in the coastal zone.
Okay, thank you very much. I think if you have any other questions, you can discuss this with the speakers. They are going to be available during the break. So I take this opportunity to thank all the speakers and the presenters for their wonderful talks and presentations. And if there are any further questions, they can be discussed during the break that we are having. And one more thing, I'm really thankful to all, because never did I have to intervene. All the speakers and presenters actually took care of the time that was allotted to them, and they confined them, their talk within that. So thanks once again. Thank you very much.